In this topic, I will explain you about the highly used plastic processing technique called blow molding. Blow molding is used to produce plastic products like hollow tubes, like toothpaste tubes, containers which are normally used for the storage of water in for domestic purpose. So hollow plastic products is normally produced with the help of the blow molding process. Blow molding. Blow molding has three main important parameters which are to be considered during the process of blow molding. What's the melting temperature of the plastic? Normally, here plastic is thermoplastics. Thermoplastics will be used in for the blow molding because of the low melting temperature. And this temperature is varied uh, with material type. Like sometimes we will use the polyvinyl chloride PVC, polypropylene PP, and polyethylene. All these material type have different melting points or melting temperatures. Air pressure is very much important, which is around 350 to 700 kilopascal, and this air pressure is used to expand the parison into the mold cavity. I will explain you what is parison later in this topic. The third thing is cooling time, which is around zero point 0.5 to 3 seconds. This blow molding has three steps. In first step, parison will produce. In second step, or in final product will be produced. Final product will be produced. As I've told you, the thermoplastics will be used in blow molding process, and when you melt these thermoplastics, this it becomes the polymer melt. In the first stage of blow molding process, that is called parison extrusion. Initial stage is just like the same as we have studied extrusion process. In the first stage, parison stage, extrusion will occur. And then this extrusion process, barrel will use, and inside this barrel there is one rotating screw, and this blue is the polymer melt. This polymer melt will flow into the tube die, and through this tube die parison will be produced. This parison has the same rounded tubular shape rounded tubular shape and over the surface of this tube there is one hole, and through this hole air will flow inside. In After the first stage, this parison, that is also called preform, is injected into the final die, and the final die has two cavities. One cavity is in the first part, another cavity in the second part. When we join these two molds, the final product will form, and final product has the same shape as the shape of the mold cavity. And inside this mold there are some bores which is used for cooling purpose. The water will circulate inside the mold through this cooling bores to maintain the temperature of the mold. And then in the second stage, this preform is injected into this mold, as you can see here, and then pressurized air will flow inside this mold through this hole. Actually, the air will flow inside this parison because parison is already into the mold, and there is one hole over the surface of the parison, and pressurized air will flow inside this parison. And what happens, this pressurized air allows the wall of the parison to expand to the mold wall of the mold cavity. It will expand due to this air. This wall will expand due to the pressurized air to the wall of the mold cavity, and this pressure is maintained until the plastic cools down, right? This gas pressure inside this tubular part, as you can see here, this is the tubular part, this is final product, and this is the tubular part. And this gas pressure inside pushes the tubular wall, as I've told you, or expands the wall of the parison until it takes the shape of the mold. As you can see, When you join these two parts of the mold, you will get this shape of the bottle. And the final stage, this molded part will be ejected through the ejector pins. This is the final stage, and you have your molded part of final product. Once the polymer has cooled, the mold will open with the help of ejector pins, as I've told you. This is all about the blow molding, basic blow molding. Blow molding has more three types. First is the extrusion blow molding. It is the same as I've explained you above. There is one extruder barrel. In this extruder barrel, polymer will melt and flow inside and flow towards this tube die, and through this die parison will produce, and this parison in the second stage will inject it into the mold. As you have seen, both the molds are open currently. In the second stage, this mold will close against the wall of the parison. This is the wall of the parison, blue is the wall of the parison, and then blow pin is installed lower part of this mold, and through this blow pin air will flow. As you have see here, this air will flow and strike to the wall of the parison, and it allows the wall of the parison to expand against the or to the wall of the mold cavity. In the final stage, after the solidification, because the pressure is maintained until the part will solidify, and after cooling and solidification, both the mold parts will be opened with the help of the ejector pins, and the final part will take out from the mold. This is the extrusion blow molding. Extrusion blow molding machine has some specification. This extruder melting capacity normally calculated in kilogram per hour. This is the flow rate, mass flow rate, how much mass is used to or normally flow into the die. The second part is the maximum output. This maximum output means the production rate. Depends upon the plastic type, what kind of plastic we are using, plastic pressure. Plastic pressure is normally 200. I have told you this polyvinyl chloride has plastic pressure 200 kilopascal. Normally the range is like 350 to 700 kilopascal, but polyvinyl requires a low temperature, low pressure. Here, I will explain you about the. I've already explained you about the extrusion machine specifications and blow machine molding machine specification versus the extruder capacity. Extruder capacity means the how much material will flow inside the die. We have to calculate in kilogram per hour. If we use the high machines, then the capacity is normally measured in tons per hour. The second one, the second was the maximum output. How many parts can be produced through the machine, extrusion molding machine? This is depend upon the plastic pressure, plastic type, and plastic mold melting temperature, and the plastic geometry as well. The size of the mold is also depend upon the machine capacity or machine size. You can use large machines or you can use large molds inside the machine. If you have a you can find a variable mold machine in the market, because through one machine you can produce different parts by changing the mold and the mold tooling. So size of the molds are very much important, and it depends upon the size of the machine. This is all about the extrusion blow molding. The large containers are usually produced, as you have seen, in the domestic purpose or for the domestic purpose to store the water. Uh, there are some containers or there are some tanks are normally used in the houses as a overhead tank. Usually, large containers, those containers are blue in color. Those large containers filled with water, and these containers are made through extrusion blow molding. The second type is the injection blow molding. In injection blow molding, that extruder barrel is replaced with the injection unit, and it take place in this process take place in two uh, molds. In the first step, injection unit, there is one plunger, and inside this injection unit there is a polymer melt or the molten material. This plunger is apply force or forces the material to flow inside this cavity. Before flowing the material into the cavity, the blowing rod insert into the injection mold, and then plunger will move forward and force the material to flow into the cavity and form the parison. Then this parison along this blowing rod is transferred into the blow mold, right? In the third step, air will apply or air will flow through the blow rod into the parison and expands the parison to the wall of the mold cavity. This is the hollow part, right? This bottle or this container is hollow inside. In the fourth step, the air is released and the mold is opened by removing the blow mold blow molding rod, and the part is take out from the mold. In injection blow molding, normally you can produce this milk bottles with the help of pad material. Pad materials or polyvinyl materials you can use. The third and the last type is stretch molding. In stretch molding, you can see here, in stretch molding, first the parison, the whole periphery of the parison has uniform temperature. From top to bottom, the temperature is uniform. In injection mold, will use the first this step is same as in the blow molding. Injection unit, inside the injection unit there is a polymer melt on a molten material. In this process you can use thermosetting plastics and thermoplastics, both types can be used. Injection unit, molten material will fill, blowing rod, or you can say it is a stretching rod, will place before flowing the molten material into the cavity. This blowing rod extend downward during the injection process, and parison will produce. And in the third step, air will blow inside the uh, or through this blowing rod, and the parison will extend downward and expand to the wall of the mold cavity. Like this rod will the both process will be performed simultaneously. Like extend the stretch rod, this stretch rod will extend into the mold cavity, right, and form a parison in first step, because the molten material will flow inside, and this rod will move downward and extends. In the third step, air will apply, and due to this pressurized air, this air is responsible to expand this parison to the wall of the mold cavity. The first step is injection molding, second is stretching, third is blowing. Like blow rod will move downward or extend downward. This is the stretching. And blowing is the expansion of the or expanding the parison wall to the mold cavity. Carbonated beverages, plastic cold drink bottles are made up of stretch molding process. Polyethylene terephthalate is normally it is called PET, and polyesters are also used to produce the bottles. The temperature of PET is around 200 degrees centigrade. Some of the PET found in with the agents or carbonated agents or the coloring agents, the temperature of the PET with the coloring agent is normally around 180 to 190 degrees centigrade, but pure PET is around 200 degrees centigrade. This is all about the blow molding. In the next topic, we will study about the compression molding. Students, in this topic, I will explain you a particular type of molding called compression molding. In compression molding, this process is performed with the help of heat and pressure. This process can usually performed in four steps. In first step, the charge, which is a thermosetting plastics. In compression molding, thermosetting plastic will be used to perform the molding process and produce the plastic products. Thermoplastic process, as you know, the high molecular weight and the internal structure is consist of cross-linking. As you know, the cross-linking structure looks like this pattern, and these monomers are linked together. All the monomers are linked together. This is cross-linking. To perform the cross-linking or to form the cross-linking products, we use a high temperature. As thermoplastic the thermosetting plastic has plastics materials have a high melting point. So this is charged, and this is the polymer, preheated polymer. Preheated polymer is already heated before placing into the lower part of the mold. Preheating at performed at 200 degrees centigrade in oven. The charge is placed in the lower half of the mold. The upper half of the mold is in movable position. This mold, both the half of the molds will also be preheated with the help of infrared heaters. Infrared heaters is coupled with the both the halves of the mold to heat the mold, upper and the lower part of the mold, and the charge is placed inside the lower mold. This charge is also preheated at 200 degrees centigrade. The force is applied by moving the upper mold of the half and the with certain velocity and the force. When the force is applied to this charge, the material or this melted polymer or this heated polymer will occupy the shape in the mold cavity, or this polymer is filled into the mold cavity. In last stage, we will use the extraction pins or knock pins. This is also called extraction pins. Knock pins will use to eject the molded part from the dies. In the last step, extracted pin is used to eject the part from the mold. This process has two strokes. In upper stroke, upper stroke or up stroke, down stroke. What happens in the up stroke? In up stroke, this lower part will be in movable condition. The upper part will be in fixed position in upper stroke. This lower part will move upward hydraulically in upper stroke and perform the compression molding. In downward stroke, the upper part will move and down lower part will be in fixed condition. So that is the downward stroke. Number 3 point is material. What kinds of material will be used, or what kind of the thermoplastic polymers will be used to perform this compression molding? Phenolics, melamine. As you know, melamine is used to produce the different bowls for eating. Epoxies to for the joint adhesive bonding, we will use the epoxies. Typical molding types, like we can produce electric boards, electric plugs, as I have already told you. In fact, automobile air filters will be produced or are normally produced with the help of compression molding. Pot handles, like pot handle means, for example, if you have fry pan and fry pan has some handle, this handle will have less heat conductivity because thermosettings has high melting point. So pot handles will be used to will be produced or normally produced with the help of compression molding. Dinnerwares plates, normal plates are also produced with the help of the compression molding, and the material is thermoplastic. In this type of molding, advantages are the less scrap normally produced. We don't need a lot of material to produce different parts. The mold, like plates, cups, are normally produced with the help of the compression molding, and all the products are not so much expensive, and low residual stresses will be produced in the molded part. The one disadvantage is that is this molding is this molding is this molding takes longer time as compared to blow molding. As compared to blow molding, uh, the pressure uh, applied in this type of molding varies from 15 to 150 megapascal pressure value, and when the material is filled inside the mold, curing time is zero point 0.5 to around 5 minutes. zero point 0.5 to 5 minutes will be required for curing. If we use the thermoplastics or thermosetting plastics, the curing time is long, and the curing time is also depend upon the material type and material geometry. If you have a long thickness or high thickness part, it will take a longer time for curing. Curing is when you use the thermosetting plastics. Uh, Normally, we have to heat this material. So curing is just heating the material and stay this material inside the mold for solidification. That is curing. Like first we heat the material, this pre-charge or the pre-volume measure charge, uh, and then when the charge is placed or filled in the mold cavity, we have to wait for solidification, and the time and the process during solidification, that is called curing. In curing process, polymerization is also performed. Students, in this topic, transfer molding, I will explain you what kind of material will be used in transfer molding, or what is the whole procedure of transfer molding. And first, I will explain what is transfer molding. Actually, it is a modified form of compression molding. Like in compression molding, preheated charge is placed into the lower mold, and both the molds, upper half of the mold and the lower mold, both are also preheated. So it is a modified form of compression molding. What happens, or what is the change or distinguished feature of transfer molding as compared to the compression molding? In transfer molding, uncured means preheating is not required, not preheated charge. The uncured pre thermosetting charge is placed into the transfer pod, but this transfer pod is preheated around 180 to 200 degrees centigrade, and then from this pod, this resin, actually resin polymer will be used. Resin is also a type of polymer. Actually, resin is poor uh, heat conductivity and water resistance, chemical resistance, is very good, and it has a poor resistance to heat and electricity. So that's why through transfer molding, as you can see, electrical connectors and electrical components are normally made. So the transfer molding, uncured thermosetting resin will place in the transfer pod, which is placed over the mold. And transfer pod is also called upper half of the mold, and this transfer pod and this lower part, this is lower part of the mold, both are preheated at 180 to 200 degrees centigrade. This resin will place, and this resin will take energy or heat from the transfer pod and becomes viscous. And when the ramp is used to apply force over this material, and due to that force, this resin will flow into the mold cavity, Actually, this resin will flow through the spur. Actually, spur is also a type of channel which is used in the pod transfer molding. Actually, transfer molding has two types: pod transfer molding and plunger type transfer molding. In pod type transfer molding, there is a spur, SPUPRUE spur will use in the pod transfer molding upper part of the mold, or in transfer pod. When the resin takes energy from the transfer pod and force is applied to this material, this resin, the flow is this the flow is highly viscous, and due to this viscous flow generate heat, considerable heat will generate, and that heat used to raise the temperature of this resin. When this resin is in the molten state, when it enters into the mold cavity, right, and it will stay into the cavity for 3 to 4 minutes for solidification, and that is the curing time. 3 to 4 minutes is the curing time. It could be less, but it depends on the type of the material and geometry of the material. In third step, this material or this molded part or this final product, and this final product has the same shape has the same shape as it is the shape of the mold cavity. The final product shape and the mold cavity shape both are same, and this ejector pin will be used or normally used to eject or pull out this part from the mold. The upper part of the mold is also called transfer pod, right? But there is one more thing, this part, this extra part which is attached to the upper transfer ram. This flat or horizontal part will called cuel, and it is the leftover in the base of the part. And this part can be removed by the help of knife from the molded part. And this is the spur. As you can see, spur is kind of cylindrical part, but the walls is at certain angle from the horizontal. It could be 10 to 15 degree from the horizontal. And this spur is also a scrap part, a scrap material, but it could be reheated and used for further molding. Reheated and used for further molding. The another type is plunger type transfer molding. In plunger type transfer molding, plunger will use instead of ram. As you can see here, but one more thing is that there is a channel. There is no spur is in the transfer pod. In transfer pod, there is no spur. Only this channel is used, or normally the material will flow from this channel into the mold cavity, right? And this flat part is skewl, and as I've told you, this skewl is the leftover material on the molded part, and this can be reused with the spur or reheated and melted and used as a raw material for the further molding. And in normally in plunger type molding, we have normally two ejector pins, and these pins are used to take out the part from the mold. This is the lower part of the mold, and this is the transfer pod or upper part of mold. But in plunger type, the only difference is the plunger will use to apply the force and the channel. There's a two difference as compared to the transfer pod molding. Sometimes in plunger type molding, this upper part is also called a transfer pod. And the material which are normally used is thermosetting, and the other material is elastomers. Both are the very you can say it is both the materials have high molecular weight, and both the materials have high melting point due to the high molecular weight as compared to the thermoplastics. And electrical connectors, electrical components, rubber, silicon parts are normally used or normally made or produced by the help of transfer molding. The pressure which is generated by the one more thing, which is the pressure generated by the plunger is about 300 megapascal, and that pressure is sufficient pressure to for the flow of resin into the mold cavity. This is all about the transfer molding.